Our second day session starts now. First session is on machine learning in IoT, handled by Professor Sarit Divagaran, LBS Engineering College, Kasaragod. So I invite Renzi sir to introduce the speaker.
Good morning, everybody. Good morning, everybody. Hope you can hear me.
Yes, sir, we can hear you.
Okay. So, welcome everybody to the second day, first session. Today, our topic is IoT and machine learning, application and use cases. So, this will be like last day we were hearing about sensors. So, some data is being sensed, and what we will do with the data. That is what we are focusing here. So, we have with us Professor Sarit Divagar, Assistant Professor in the Department of Computer Science and Engineering in LBS College of Engineering, Kasaragod. He is also doing his research in Cochin University of Science and Technology, USAT. Let me read his biodata. Sarit Divagaram is a research scholar at Cochin University of Science and Technology, Kerala, India. He is an assistant professor in the Department of Computer Science and Engineering, LBS College of Engineering, where he has been since 2015. He received BTech from Cochin University of Science and Technology and MTech from Mahatma Gandhi University. He is also the master trainer of Artificial Intelligence and Machine Learning course offered by Additional Skill Acquisition Program, ASAP, Government of Kerala. His current research includes machine learning and deep learning in computer vision applications. So welcome Sarit Divagar sir to this session. I'm handing over the session to you.
Yes, thank you, sir. First of all, I would like to thank EC department for giving me this opportunity to deliver a session. Let me share my screen. Yes. Yes. Hope my screen is visible.
Yes, sir.
Okay. Okay. Good morning, all. Okay. Today I'm planning my session by introducing machine learning, the basic concepts in machine learning. Then I'll be looking at the machine learning pipeline, like when you have your data with you, how you are going to use machine learning methods, like you can pre-process your data, you can do some kind of feature engineering, then how you are going to build a model, so and so. Okay, so the next session I'll be discussing about the use cases and IoT applications. Then I'll be doing an hands-on session. There we are going to use a data set from Kaggle. There we are going to do a prediction, like you have a data set where you have energy usage, say for example energy usage for past 30 days, and based on the energy usage for the past 30 days we are going to predict energy usage after 5 days. Okay, so that is the agenda today. So what is machine learning? So we can just define machine learning like a computer program that is said to learn from experience Okay, so I'll be always connecting to the hands-on session that we are going to do. So here the data set that we are going to use is energy usage data set. Okay, so that is the experience I'm talking about. So a computer program is said to learn from experience E. So the E that represents the energy usage data set, and with respect to some task T. So what task that we want to perform? So our aim is to predict the energy usage for tomorrow, or maybe day after tomorrow, or maybe after 5 days. Okay. And it is actually based on some performance measure. So what kind of performance measure we are going to use? In this kind of application, the performance measure I'm going to use is called a mean absolute error, or you can use mean square error or root mean square error. These are the performance measure that we are going to use. Okay, and now how we are going to improve? Okay, so we have to perform learning. So that is a very important task in a machine learning. We are going to learn from our data. Okay, so learning means improving with experience, or no, at some task T. Okay, so that is overall definition about machine learning. So those who have already worked in traditional programming, so you might be familiar with writing your own code. So let us have a look at some of the scenarios where you have to do hard-coded programs. Okay, so let us consider a scenario where you have accelerometer data with you. Say, based on the accelerometer data, you have to predict whether you are walking or running. Okay, so that is a task that you have to do, and the data set that we are going to use is accelerometer data, maybe from your mobile phone, or if you have separate devices for that, it's absolutely fine. So here, when you want to write a program, say maybe in a programming language like C or Python or any other programming language, so there we are going to write the rules, right? Okay, if the accelerometer data maybe after a particular threshold, we may write a if condition. So like no, after that particular threshold, you are okay, you say that okay, the person is running, or maybe below that the particular person is walking. But that may not be no applicable to no every person. Like no, maybe if you are going to read data from say a 3-year-old child, and if you're doing the same maybe for a person who is having an age 30, then it will be anyway entirely different. So when you do these rules hard coded in your program, then no, you may have to no change it many times. Okay, but how this machine learning actually solves this kind of problem? Okay, and majority of the applications, the ML based applications, use the supervised learning. Okay, basically you can divide this machine learning into supervised learning and unsupervised learning, and there are other concepts as well, like reinforcement learning and all. So here today we will be focusing only on supervised learning. So the supervised learning means we have our data with labels. The labels in sense we have our results with us. Okay, so let us take this example. Say here the accelerometer data that you are going to send to this supervised learning algorithm. There are different kinds of supervised learning algorithm that I will discuss later. Okay, so accelerometer data that has been sent to the supervised learning algorithm, you can think like you have a table of data, and in the table of data you have no the different scenarios where no where the person say the labels are like you have a person walking, and maybe the speed like can be say 10 meter per second square, something like that. Okay, so all the data in this data set is labeled. Okay, so we are going to use a supervised learning algorithm to train from this data. So the machine will automatically learn from this data. Instead of writing rules hard coded, the algorithm itself will extract rules from this data. So that is the
Excuse me,
basic.
sir.
Yes, yes.
Please make the presentation mode. Please make it in presentation mode. Slideshow mode.
Okay, it's actually in Google Slides.
Oh, any difficulty?
Yeah, I can make it. Fine. Is it fine now?
Participant requested.
Yes. Is it okay now?
No, it's okay.
Okay.
Thank you.
Okay. So again, here we can see the rules learned here. Okay, let me connect. Just a second. Okay, so you can think about a data set. Say you have two columns. In the first column, you have the accelerometer data. Okay, and in the second column, you have say the labels. Here the labels means whether it's walking or it's running. So this is the data set that we have. Say this data set is having maybe like 50 samples or 100 samples. Usually in machine learning, no, if you have a data set that is having more than 50 samples, that is enough actually, but it's not. You cannot say that it's absolutely fine to build a robust model, but minimum you should have at least 50 samples. Okay, so this is a data set that you have where you have all this accelerometer data in the first column, and here you have your labels. So this kind of data set you can use in a supervised learning where you have these labels with you. Now this accelerometer data has been sent to a supervised learning algorithm. So in this example, maybe you can have an algorithm which is of category classification algorithm. Okay, there are many kinds of classification algorithm in machine learning. You can think like we have a decision tree. Decision tree is a kind of a classification algorithm. Okay, so the decision tree makes decision, okay, based on the the model that has been built by the decision tree learning algorithm, and now it will learn, and it will store all these rules. Okay, and you can think like maybe the cutoff here. So this is the cutoff. Okay, if it is greater than that particular cutoff, you can say that it is running, otherwise it is walking. So that is the rules learned by this machine learning algorithm. Okay, but it is not actually hard coded like the normal computer programs. Here now the algorithm is learning from the data set that you have provided. Okay, and when you have more and more data, now the algorithm will improvise its rules. Okay, and we are going to measure the accuracy of this prediction. Like when you send a new data to these rules, like we can see we are going to send some live data to these already learned rules. Okay, it will predict whether you are walking or running. So in machine learning, we also have a concept called test data set. So we are going to send, say this is our original data set. So we may keep say 30 samples for the training purpose, and we may take say 20 samples for testing, for example. Okay, so in testing data set, we already have all this accelerometer data with you, and also the corresponding labels. Okay, so I didn't show here. Maybe you can think like you are going to send some test data to the already learned rule. Okay, so here the algorithm, the model that will predict whether you are walking or running. Okay, based on the test data set. So since we already have these labels in the test data set, okay, you can always compare your result. So the results that you are going to predict with the already the labels in the original data set. Okay, say
Sir,
like,
excuse me,
yes,
sir. Sir,
yeah.
are you showing some data set?
No. I have just drawn here. Can you see that?
No, we are not able to see.
Okay, in the slide itself, I'm drawing. Okay, just a second. What about now?
Still, we cannot see anything on your slide, any drawing on your slide.
Okay, actually I'm writing. It's not visible.
No, not visible.
Okay, okay. I'm not sure. Okay, then I'll exit that application. Okay, I'll continue with the presentation only then.
Okay,
Okay,
that's fine.
yeah. Okay, so what we have discussed is like we have a trained data set. We also have a test data set where we will actually compare our predicted results with the test data set labels. Okay, then once the model is ready, you can deploy this model maybe in any kind of any kind of embedded system also. Okay, so the model will automatically predict whether you are walking or you are running. Okay, so based on this live accelerometer data, you have this prediction. So that is all about supervised learning. Now, one of the pioneer in machine learning, Andrew Ng, is a co-founder of Coursera and a former head of Google Brain. So he states his approach to building a machine learning software. It has got 3 stages. It starts with an idea, then you have to implement the idea in a code, maybe in a programming language. Then you have to carry out an experiment to conclude, like you have to measure the accuracy. If it's a classification model, then you have to say, okay, my accuracy is above 90% or 95%, and you can say that, okay, it works well. Otherwise you have to iterate it again. So the faster you go around this loop, that is idea, code, and experiment, the more progress you are going to make. So that is a approach for building a machine learning algorithm or machine learning software. So it's not a easy task, like when you try it for the first time, you don't expect to get a better accuracy, like say 90%. Maybe you'll be getting say 40%. Then you have to do a lot of changes to your idea. Maybe you have to do some kind of pre-processing to the data set, or you are going to change your features. You may have to add new features. Sometimes none of this works. Then that may be because you have limited data. Then you have to add more and more data. Okay, so then you tweak your idea, then again you code it and experiment. So that's the way to build a machine learning project. So that is a approach suggested by Andrew Ng. Okay, now there's a question like, do you need math to work with ML? Yeah, the answer is it is not required, but it will definitely help. Okay, so nowadays we have a lot of frameworks like PyTorch. Then you have TensorFlow, and you have APIs to work with. You don't have to actually write all the codes from the scratch. So you have all the frameworks with you. We have a framework called Keras, okay, that we are going to do hands-on session. But a little bit of math will always help. Okay, so the question is like, how you are going to select the right algorithm for your problem. So that decision you have to make by yourself. None of these frameworks will help you to choose the right algorithm. So once you choose the right algorithm, then the frameworks will help you to implement it. That's it. Okay, then the parameter setting. So once you once you iterate over the loop, you start from idea, code, and when you do the experiment, you may not be getting a better results. So then you have to make some changes to the parameters. So that is actually some kind of a trial and error method. Okay, right? We cannot say like, by choosing this set of parameters will help you to get a good results. So you may have to try it again and again. You have to keep on changing all the parameters. There's a term for that we use in machine learning. It's called hyperparameter tuning. So we have to try it by experimenting. and there are scenarios where your model may be overfitting your data. Overfitting in the sense, if you have your training data, and all the predictions that you made is actually overfitting to your training data. Okay, actually I want to show an example by drawing the figure, but okay, let me check in Microsoft whiteboard. Okay, is it visible now, this whiteboard?
Sir, it's not visible. I think you have to share that. Now you are sharing your slide only. So I think you have to share your whiteboard. Stop sharing this and then
Okay, let me share my entire screen, then I think it will be visible.
yes.
Okay. Yeah, is it visible now?
Yes, sir.
Okay. Okay, so you can you can think about a scenario where we want to build a data set, say for predicting whether you are walking or you are running. Okay, so the same data set that I'm going to use. Okay, so previously I mentioned about this data set. So this data set is having two columns. Okay, this first column is your accelerometer data. Okay, then you have these labels. This is whether you are walking or running. Okay, so this is your data. Okay, and here you have these labels: walking, walking, and running. Okay, say now you're going to build a model, okay, for this data set. So when you do this training process, so as I said, you can divide the total. There are 50 samples. You can divide into 30 and 20. Okay, now when you build a model, there are chances like this model may overfit your data. Say your data points, say here it is running. Say these are the data points that you have. Okay, it's a classification model. These are the data points that you have. Okay, now when you build a model, usually nowadays we have very complex models. When you do a model, no, the model may overfit your data. So this is walking, this is walking, okay, this is walking, and this is running, this is running. Okay, now what will happen is that when you build a model like this, okay, and which separates this walking from running, so it is making a classification like this. Okay, so this part it is walking, and this part it is running. So that is a classification model. Okay. You can say that this kind of model will overfit your data. This is your training data, and this is the model that you have. Usually, if you are going to build a very simple model, okay, and it will be like this. Okay, the same data set. This is walking, and you have one running over here, and this is also walking, and this is running. Okay, when you have a very simple model, so the model will be something like this. It separates this walking from running. Okay, but there will be one misclassified case while training, but doesn't matter. You already have, say for example, 99% training accuracy, but in this case you have 100% training accuracy, but you cannot say that this model is good. The reason is because here we say that it is overfitting your training data. Right. So now what we have to do in these scenarios, you may have to do more hyperparameter tuning. You can introduce more concepts, like we have a very important concepts in deep learning world that is called dropout. Google as the pattern of dropout. So I'll be discussing when we discuss about deep learning and all. So the aim is to build a robust model so that when you do testing, okay, you have very less error. So this is the concept of overfitting. And no, when you are going to have a very complex model, and if you have a simple, sorry, when you have a very large data set, and when you're going to have a very simple model like this straight line, then there may be some scenarios where you will underfit also. Like you are expecting your model to go like this. Okay, so this is walking, and you have walking. Okay, so you expect some kind of a polynomial model here. So like it should go like this, but you have actually a very simple, straightforward model. So that is the case of underfitting. Okay. So anyway, those are the things that you should understand when you work with machine learning projects. Okay. Now coming to the machine learning decision tree. Say you may have to follow this machine learning pipeline when you get a machine learning task. So the first question obviously is whether the problem in your hand is suited for a machine learning task. Okay, so if you are not going to use machine learning, then absolutely fine, because that problem doesn't suit for a machine learning task, right? Now for example, no, you are going to build a artificial intelligence robot that will give you some response based on the question that you're going to ask. Okay, so there you have to make a decision whether the robot is going to learn from the data, or whether based upon some predefined rules, the machine is going to answer the questions. Okay, so there it's about you to decide whether you want to use the machine learning, or whether you want to just stick on with the basic artificial intelligence techniques. Okay. And if you are going to choose your machine learning task, then is it correct machine learning scenario? So that's the question that you have to answer. Okay, and later you have to choose the best model for your machine learning projects. Okay, and we will be discussing this pipeline when we discuss our hands-on also, as we are going to use the data set, and also we are going to do some kind of pre-processing with the data set. We are also going to do some kind of feature engineering with the data set, and finally we are going to evaluate our results against some performance metrics. The final aim is when you choose a model, and when you extract features, and when you test it, when you test your model, and the final questions that you have to answer is, okay, whether you have a good result. So that is a final aim, whether no, you have a good accuracy. So whatever you do with your data, and whatever feature engineering that you do with the data, the final aim is you should have a better results in the end. Otherwise you have to follow that iteration again. You have to you have to code, then you have to experiment, you have to make some changes, then you have to again code. But still, if you think that it doesn't work, then you may have to change your idea as well. Okay. So let us just write this ML task. Say you can think about a scenario where you have a value x that is independent of y. Okay, and you may have to predict, say for example, height of a person based upon age. Okay, based upon his age, maybe you can think based upon his age and weight. So do you think there is a relation between this age, weight and height? Okay, so here we can say that, okay, I'm going to remove age because there will be some dependency between age and height. Okay, say there's a weight, you have say weight, okay, and you're going to find the relation between weight and height. Okay, so here, okay, better I will write height here, okay, because height is the dependent variable. Okay, so this is weight. So in x-axis you have weight, here you have height. Okay, so you want to choose a machine learning task. Okay, but what you have is weight with you, and you have to predict height. Okay, so here this is x. Okay, that is the value that you have, and this is y, okay, that you want to predict. So based upon weight you have to predict height. Okay, so you have your data set, and I'll just mark these labels here. Okay, okay, so it's a very scattered data set, and no, you are not able to find any relation between this weight and height. In that scenario, you can say that this is a very hard problem. Okay, it's very hard problem where x is independent of y. Okay, if you want to build a model using machine learning, you should have some dependency between the variables that you choose. Okay, there should be some dependency between weight and the height. Okay, now you find a scenario where you have age and you have height. Okay, in this scenario, the task is very easy. Maybe you can write this in terms of a function y is equal to f of x, where x is the dependent variable. Okay, and you can say that there's some dependency. You can write a function. Okay, maybe you can think about a very straightforward function like a straight line. This can be also your model. Okay, where there is a relation between age and height. So age starts from say like 1, maybe 50, or like let it be 100. Okay, and you have height say 10, 170 centimeters, something like that. Okay, so there is a straight line. Maybe you can write this may be your final model. Okay, so here we have a machine learning task. Now you are able to configure it in this way. Y is equal to f of x, right? This is your function. Y is equal to mx plus c. It's a straight line that you have built based upon this data. So this, let the data points is like this. Okay. Okay. So now the second question, whether it's an appropriate ML scenario. So for that, you have to decide whether it's some kind of a supervised learning or it's kind of an unsupervised learning. So supervised learning, we have seen so many examples now. Unsupervised learning, like now you have, say for example, you have a bucket of apple and mangoes, and right, you have to separate them. So like you have apples grouped together, you have mangoes grouped together. Okay, so based on some algorithm, there are many unsupervised algorithms in machine learning. One of the example is clustering. There's a technique called clustering techniques and all. Okay, okay. Now, the third question that we have asked is whether the model is appropriate. So, if you have very small data, you may have to go for a linear model. Like if you have only 10 samples, you may have to go for a linear model. And if you have very large data, the option is going for a non-linear model. Okay, now with deep learning and all, we can build very complex model using deep neural network and all. Okay, that's the question that you have to make. So whether you want to go for a linear model or if you want to go for a non-linear models. In the we have also seen a scenario where your data actually requires a polynomial model. Okay. Now the another question that you need to answer is like whether your data is imbalanced. Okay, so like if you have a data set that will have say some records of patients, and you have to predict whether the patient is having say cancer or not. So in those kind of a data set, no, you may not be getting so many samples with the patients that is having cancer. Okay, say for example, in your data set, say you have 90% of the data is having patients with no cancer, and only 10% of the labels is having cancer. Okay. So this kind of data set, you can say it's a imbalanced data. So now coming to IoT, you can take the same accelerometer example where your data set have say 38 entries that belongs to walk, and you have say 12 entries that is running. So this is not imbalanced data set, but it's a good data set. But you consider scenario where you have only 48 and 2, only 2 entries for running, and there are 48 entries for walking. So this is actually an imbalanced data set. So in those scenarios, you have to some special treatment no, to balance this data set. Okay. And the next question that you have to answer is whether you have enough training data. Okay. So if you have more and more data, then you can obviously improve your model performance. So that's a proven thing in machine learning world. Okay. And we have also seen the case of underfitting and overfitting. So you have to always start with a very simple model. You have to evaluate the performance of the model. So you have to always go through the iteration. You get your idea. Okay, so you have your idea first, then you code it. Okay, so this is idea, you code it. Okay, and you evaluate. So when you evaluate, say you have got only 50% accuracy, then there may be chance like your model is very simple, then you can go for a more complicated model, so that when you try it again, so you have say 70% accuracy. Okay. So, but make sure when you make it your model more complex, you should not overfit to your training set. Then what about the feature quality? So there comes the technical feature engineering. Okay. So whether you have identified all useful features. Okay. Say you have a data set. Say let the data set be no, identify a number plate. Okay. You have to read characters from a number plate. Okay. So that is a problem in hand, and now earlier days we have a lot of image processing techniques to read your data, but nowadays we are not going to manually extract features from a number plate. Now since we have a deep learning, so there are different deep learning techniques, like we have a convolution neural network and all. It will automatically extract features from this image. So this is an image that is captured by a camera, and you have to automatically extract features. Okay. And earlier days, we may have to go for a domain knowledge experts to extract features. Okay. And you can think about another scenario. Let it be a medical image. Okay. Say for example, let it be an X-ray. Okay, and you may have to consult with a doctor to extract features from this medical image. Okay, so that's all about identifying useful features. Okay, now if you are going with numerical data and all, so the example that we are going to use today, we have a energy data set. Okay, we have a lot of appliances. Okay, the different appliances used in a house, and based upon the appliances usage, you have to predict the usage, the total usage maybe after 5 days. Okay, so in those scenarios, you may have to look at the entire data set, and there may be some features that may not be useful to you. So those kind of feature engineering is very useful. So we'll be doing some simple feature engineering when we do the hands-on session. Okay. Anyway, you cannot say beforehand like whether the two features chosen by you will perform well or not. Finally, you have to evaluate the performance, and if you are not getting a good result, then you may have to go back again and change the features. Okay, maybe combine some features, maybe you transform your features, so and so. Okay. So the next one is about combining your models. So that's the last option. So if none of this works, and if you think like when you can combine two or models together, and now you'll be getting a better performance. So that's the technique is actually called ensembling in machine learning. Okay. So this model validation, and we'll be discussing during our hands-on session. Okay, so that's a very quick introduction about machine learning. I hope the concepts is clear to you. So if you have any doubt, you can ask me at the end of the session. Okay. Now coming to the IoT, so as we already know, we have a lot of devices that is connected and communicate with each other. But there is one important term that you should understand when we see an IoT. It's about integrating all these devices. If you have your IoT devices running in silos, there is no use at all, right? So you want to integrate all these IoT devices together. Okay, so that is a that's very crucial for improving your life quality when you think about a smart home or smart city or any kind of applications that you are going to develop with Internet of Things. Okay, say this big is the IoT market. So I hope you will be aware of the number of devices that is connected now. We have 2 billion in 2006 is coming to 200 billion in 2020. So that's actually projected, but it's going beyond that. So you have that many devices now, and due to this, the development of hardware and also the development of uh, the the algorithms, the more and more complicated algorithms are coming into the machine learning world, and you are also generating a lot of data. Okay, and we hope you know about the computation power is keeping on improving. So there are many technologies that is improving at the same time. Okay, so I'll just introduce some of the key terms, some of the buzzwords in the industry now. So anyway, we have also already seen about machine learning. So you have ML, you have IoT, then you also have heard about big data. Then there is data analytics. Okay, so here I'm going to talk about big IoT data. Okay, usually the business, they perform data analytics using the standard data analytics. So maybe you can think about statistical techniques. But now this data analytics also is using machine learning. Okay, but since the data has grown over years, we have so much data right now, and we usually don't call it as a simple data. That's why we call it as a big data. And in our scenario, we call it as big IoT data. So why it's big IoT data? There are three reasons for that. Say the first reason is the volume of data. So you can think about the data that is gathered from a traffic. Okay, right? You have traffic data, maybe from the traffic signals, or maybe the cameras attached, or maybe the moving vehicles is sending data. The GPS data that has been sent. So we have a lot of data. So this traffic data is contributing to the volume of data. Then what about the health, right? If you are having a wearable band with you, and it is sending data every seconds. Maybe if you are sending it for every minutes also, you have a lot of data. Then about the energy management applications, like if you are planning for a smart home. So in the case of smart home, say you have your appliances sending data maybe every minute or every hour. So that is a huge volume of data. So how you are going to deal with this huge volume of data? So for that you need technologies. You need technologies like big data analytics. Okay, big data analytics. So that is a terms that has been coined for dealing with big data. Okay, so the algorithms are the same. The machine learning algorithms are the same, but there are some changes in the technology in the way we used to deal with the data. Okay, so that's about the volume of data. Now, what about the velocity of data? Right, the speed at which the data been sending to the server. Usually you have a lot of sensor data, so a lot of devices, then you are sending it to a server. Usually we send to a server, or it can be a Google cloud. Okay, and the frequency of the data we measure, maybe it is in seconds, or maybe measured in hourly or in minutes, so it contributes the velocity of the data. So that's about the frequency, right? We term it as velocity of data. And no, the third term is about the veracity. Like, now we have different sensors with you. We have, for example, you can think about an agriculture based application. Okay, agriculture-based application. We have a temperature sensor. We have a wind speed sensor, or we can, there's a rain gauge. Okay, so there are a lot of sensors. So these sensors collect data from heterogeneous sources, and know that kind of data may be of different ranges, right? So there we term it as a veracity of data. The data is of, may not be of the same format, may not be, the range of values will be different. Okay, so that term is called veracity of data. So to deal with this kind of data, that is different volume of data, right, velocity of data and veracity of data, it's not easy for you to develop an application from scratch, right? So a lot of frameworks has been developed to deal with this kind of data. So I'll just introduce you one of the frameworks that has been developed by Cisco and Teradata. Okay, so I have already shared it in the PPT yesterday, so you might have gone through that link, so where you can actually read about those frameworks. So this is a framework that has been developed by Teradata and Cisco. Okay, so this part, the left part, okay, this part you can think this this is your IoT part, and this is the API to connect to the cloud servers and all. So that has been developed by the Cisco, and that is, which is marked in orange color, you can see over here. This is the Teradata framework, where you perform all this analytics or the machine learning. Okay, so that's overall framework. If you have not gone through the link, I suggest you to go through it. Okay. Now, coming to the smart city, so let us see some of the use cases, and we'll discuss one or two applications corresponding to each use cases. So, in a smart city, you can think one of the popular applications. So, government is also have issued a lot of challenges right now to come up with the problems related to smart city. So one of the solution to a problem called parking problem. So you might be very familiar with the issue. So nowadays in cities, it is very difficult for us to find out the parking space, right? So one of the solution using IoT and machine learning is to you can you can search for parking space in a city by just clicking a button, right? So suppose you are in a city and you want to park your car. So you have to just press a button. Maybe it can be an app, or it can be also an SMS base if you don't have a smartphone. Okay, so what it does is actually it will find it based upon your location. It will find your it will find your location, and it will suggest you the nearest parking space, parking plot that is free. Okay, so it actually uses IoT, and it is also using the machine learning. So where the machine learning part comes in it. So there it's actually looking for the free slot, and it is actually looking for the nearest parking spots. So that will also help you to save your energy as well. Okay, so these kind of problems is in you can deal with IoT and machine learning. And another scenario, you have some static resources in a city like fire force, ambulance, and all. Suppose some drastic event happened in a city. So if you have, if you can connect all these resources together, and the way the fire force can approach to that particular even no, maybe you can speed it up. So these are the scenarios where you can actually use IoT and machine learning. Now, another scenarios, I hope you might be aware about the consumers survey that has been taken, by AMI. So it's a COMI, the Chinese company. So according to their survey, 70% of the consumers improved their home during COVID-19. Okay, they actually bought a lot of smart devices to your home. So these smart devices help you to say, for example, you can consider an example like when you're going to set your alarm clock, say at 7 a.m. and you also set your coffee brewer to dispense coffee, say at 7:15. Okay, so that is a scenario. And sometimes when you hit snooze button to your alarm, what will happen is like the coffee is already made at 7:15 a.m. and you woke up at 7:30. So what will happen? The coffee will be very cold, right? So in when you can integrate that with machine learning. So if we are going to integrate these smart applications with machine learning, so when you hit the snooze button, the model will automatically understand that you are not going to wake up now, so it will alert this coffee brewer, like, okay, is going to wake up, not going to wake up at 7 a.m. So it will suspend until the person wake ups. Okay, so there it's actually learned from the past data. Maybe usually the person used to hit snooze button for twice, or in some of our cases maybe thrice, or maybe more than that, right? So it depends upon the previous usage history. The model will automatically expect the person to wake up after hitting snooze button for maybe 3 times. So you are actually getting a very hot coffee. So that is the scenario where you can combine this IoT and machine learning. Now, another use case is about the Google project, which deals with air quality. So we have to always focus on our environment. Say you might be very familiar with Google Street View map, okay, where you can actually see all the street view when you launch the Google Street View application. But these Street View projects, they are also having a device to track the air quality, maybe the presence of carbon dioxide or carbon monoxide in the atmosphere, or any other particles. So they are actually measuring air quality also. And if you are having an application, if you are going to build an application based upon this project, like the application will suggest you to, if you should not go for a morning walk right now because the air quality is very poor. So you may have to either skip it for today, or maybe it will suggest like, okay, the air quality has improved now, or it will suggest you like, okay, tomorrow better you go for walking before 6 a.m. Otherwise, you'll be getting a very poor air quality. So this kind of application is also very useful. Then another scenario is very common thing right now. There are a lot of cases about depression. So we also have heard about the Bollywood star Sushant and all. But now UCLA University is integrated. Now they have made a tie-up with Apple to develop an application that will send you some insights about depression. So if you can have a device, a wearable device like a watch, and it will frequently sends data to a server. It can be a server stored in cloud, and based upon your sleeping pattern, or based upon your mood, now it will send some insights. So we already have a model deployed based upon training data, and now it will suggest whether the person is having depression or not. Okay. Is the data set is actually they are going to build. Okay, they are going to ask no, it's a project now just started only, so they are going to ask many volunteers to come and no, they will track their progress, right? So some of them will be having depression, so there that will be marked as a label, say they have depression, and there are volunteers who don't have depression. So right now we don't have any frameworks to solve this kind of challenges, right? But no, you already have a method where you will directly ask a person, are you feeling depressed? That is the only way to do right now. Okay, so once you have this model ready, then based upon the sleeping patterns and also other uh, sensor data, so the model will automatically predict whether he's having a depression or not. Okay, that's an ongoing project developed by UCLA along with it's a California University along with Apple. Then those who have no, those who have already visited a decathlon for purchasing any sports item, so you might be very familiar right now. So you don't have to actually go and pick all the items. You can directly visit the stores. Okay, if you have app in your hand, you can just scan those items. You just want to scan the items, and when you check out at the counter, all the items will be ready. So you don't have to take a trolley with you to pick all the items. Okay, so they are actually using RFIDs to increase the inventory visibility. So in this study, so it's actually about the inventory visibility, where from the production to the throughout the supply chain, they are using RFIDs. Okay, so RFIDs attached to each and every device in Decathlon. So even if it is very small, so you might be very familiar with the RFID devices. Now the cost of RFID devices is also very low, so its usage has been increased drastically, and so that will give a better checkout experience for users. So that is one of the business use cases where this IoT has been used. And now, like no, when you are going to visit a decathlon stores and you have picked some items, now using the machine learning and all, based upon your previous purchase behavior and also the already existing items in your cart, now it is suggesting, okay, the people who bought these two items also bought this, or no, they will be suggesting you more and more items according to your usage history, or according to the usage history of other users as well. Okay, so that is a better customer experience based upon the technology developed. Okay. Now coming to the last slide of these use cases, we are going to have a system that will predict the energy usage. So when usually the energy usage trend may be very similar, especially in this pandemic. Most of us are working from home, so the energy usage bill, it will be on a high end. Okay, so if you have an application that will give you some prediction about the energy usage, maybe after 5 days, maybe you can plan accordingly and try to reduce it. Okay, so let us start with our hands-on. Then we will be going with the remaining discussion about deep learning. I'll be going through the theory part, remaining theory part, along with the hands-on session. Okay, so if you already have this Google Colab ready, then you can launch the Google Colab. Or if you have this Kaggle, this is a Google Colab window, and I have already shared it with you yesterday. You can, if you followed all those steps in this Google Colab, you can right now you can work on it. Or if you are comfortable with Kaggle, then you can go to the Kaggle link and you can launch. You can click on it. If you have registered for Kaggle, you can edit it and you can launch. You can run these programs along with me. Okay. So maybe I'll be giving just 2 minutes for everyone to launch this Google Colab or Kaggle session. Or if you have any other doubts also, I think you can ask me right now. Renzi sir, okay, we are going to start this hands-on session. So We'll give 2 minutes for the participants to just launch it.
Okay.
Okay.
If the participants have any doubts, they can put them in the chat box. You can proceed, sir.
Okay. Okay. I hope this is clear now. Are you able to see it properly? About the font size?
I think it is fine.
Okay. Okay. So if you're working in Google Colab, now you have to mount your Google Drive. Okay. So when you try to mount your Google Drive, it will ask for your Google password and all. Okay. So here it is already mounted. Okay. So for those who are working in Google Colab, so I have already asked you to upload this file. It's a zip file. You have to upload it in your Google Drive. Okay, so once it is there in the Google Drive, so this particular command will help you to extract the zip file, and you'll be getting the CSV file. So CSV file is a comma separated file, and this comma separated file is having your data set. Okay. So I have already archived it. Okay, so I'm not going to unzip it again. So this is the CSV file that you're going to work with. I hope your CSV file is already ready. Okay, and those who are working in a Kaggle session, you don't have to actually use the zip file, because you are already going to use the data set. Okay, so let me expand my window. Okay. Okay, so this is the Kaggle interface. You already have this data set, that is smart home data set with weather information. There you can just run your cells by clicking. You can just click on the cells. Once you edit this particular notebook, you'll be starting a kernel. Then this is the way to run the cell. You click on any cell. Okay, and there's a run button here. So don't press run all. You can run cell one by one by clicking on this run button. Okay, so this is the first cell in Kaggle where you have to import all the required packages for you to run. Okay, so just click, select those cell and click on the run current cell button. Okay, and similarly in Google Colab, so once you mount your data, once you extract it, here also this is a cell. Okay, here you can click on the runtime. Okay, and you can run the selection. Okay, or there is another option. You just click on Shift and Enter, so that will also run this particular cell. So these are the two methods that you can work with. Okay, now about this particular code. Okay, here we are importing the required packages for you to work with. The first package is called NumPy. So it's a scientific computing package in Python, where it will help you to perform many mathematical operations. Okay, and you have a pandas package in Python. So anyway, we are getting in this data set as a CSV file. So when you open it in Excel and all, you will be able to see this data set in a tabular format. Okay. So CSV is nothing but a comma separated file. It's actually a text file where each column is separated by a comma. Okay, so pandas will help you to read it directly into a data frame where you can visualize your data in a tabular format. Then you have a package called matplotlib, so that will help you to do the plotting. Okay, you know this MATLAB, Matplotlib, and Seaborn also is for data visualization. Okay. And this particular cell will help you to plot your images in this Jupyter notebook itself. Okay. Now let us look at the data. So whenever you have a machine learning project, then when
Sir,
you have this data, yes.
Participants are asking to slow down your pace of presentation because their data set is still loading up.
Okay. I'll just wait for 1 minute then.
Sure.
So that they can just load it. Yeah. Okay.
You can see your chat box also.
Okay.
Meanwhile.
Actually, I have hidden it somewhere else. It's not showing up. Yes. Okay. Yeah, authorization code. You have to click that link, and it will take you to your Gmail account. So you can get the authorization code from there.
Sir, how to unzip the Hope.csv in Colab?
You don't have to unzip it by yourself. You have to just upload the zip file to your Google Drive. Okay, and
Already done, sir. Already done, sir.
Then when you run this cell, okay, it will automatically unzip it. This line of code.
Unzip drive, I drive.
Okay, hope you have also uploaded this entire Colab file in your Google Drive, right?
Okay.
Should be there in the drive also.
Colab should also be there.
Yeah, Colab should also, you have to upload it. It is actually working in cloud. So you have to upload your Colab also, and also the file if you're working in Google Colab.
Sir, please can you show that one, sir? We are working that one on first time, sir.
Kaggle, you're talking about?
No, sir. Collab only.
Colab, see, I have given you the link. Okay, so this is the GitHub page. Okay, there you can see this file. Okay, machine learning for IoT.ipynb. This is the file. Okay, what you can do, you can just click on draw. Okay, then you can use Ctrl+S to save it in your computer. So when you save it in your computer, make sure you put a double quotes over here if you are in a Windows. Otherwise, it will treat it as a test document. And you can save. Okay, I'm saving it in my desktop. Okay, machine learning for IoT.ipynb. I'm saving it in the desktop. Then you have to visit this page, this link. Okay, that is there in the insertions. So you have to go to the insertions page. Okay, so here in the prerequisites, I ask you to visit this link. Okay, collab.research.google.com. So when you visit that, a pop-up like this will come where you can upload the notebook. So you click on the upload button, then you click on choose file. Okay, so I have saved that Google Colab notebook here. You can just select it and open. So it will get uploaded in your Google Drive. Okay, that is one option. Or if you can directly upload in Google Drive and right click and open it Google Colab, that is also fine. Okay, these are the two methods to work with Google Colab. Okay, but Kaggle is pretty easy. No, you can just directly go to the link. Okay, just go to this link in Kaggle. You should be able to see the edit button if you have already registered. So I asked you to register it yesterday. So if you're registered, you can see this edit button. So when you click on edit, okay, the kernel will get started. There you don't have to worry anything about the dataset because the dataset is already loaded in Kaggle. Okay, so you can see the code. When I explain each code, you can click on the cell and you can click on the run current cell button. Okay, so those who have not yet uploaded the zip file and all, I suggest you to go to Kaggle because that is pretty easy right now. Okay, okay. Any other questions? May I continue with the discussion?
Yes, sir.
Okay. Yeah, authorization code. You have to click that link. It will take you to your Gmail account. From there, you can copy it. Okay. Okay. So, okay. So this particular code will unzip your file, and you'll be getting a CSV file. So this code I have already explained. It's about importing packages, required packages. Okay, now let us try to analyze your data. That is the first thing that you have to do when you work on a machine learning project. Okay, you have to analyze your data. Okay, so in Python we have already imported the pandas module. So I have imported pandas as PD. So I can directly use this PD as alias to read your data set. So the command is to read your CSV file. So for that we have a read CSV function. Okay, so when you point out this PD, you can see the documentation of pandas is coming. Now the data, the entire data set, the entire data, entire CSV file is in a data set. Okay, so this is a data frame object. Okay, and there's a function called info. When you run this cell, you will be able to see the information about the number of features in your data set. Okay, so when you run it, you can see here you have a total 32 columns. Okay, and there are total 50,3911 entries. Okay, and here you can see your corresponding columns. Okay, the columns, the first column is time, that is your index column. Then you have the use of, that is the total use of all the devices in kilowatt. Then you have the energy that is getting generated by if you have a solar or something like that. Okay, then this is a house overall field. Maybe there will be some repetition of fields because that is where this data has been stored. Then the energy used by dishwasher, furnace, home office, fridge, etc., etc. So you can see all those information over here up to this part. Then you can see some weather information also, like there's a temperature, humidity, visibility, okay, apparent temperature, dew point, etc. Along with that, you have two more categorical columns, that is called icon and summary, like whether it's a sunny day or it's a rainy day and all. Okay, so these are the columns in your data set. Okay, so once you get a data set like this, maybe no, you may not be getting an integrated data set like this. Usually, no, you have multiple sensors, and you have to actually do more pre-processing to integrate into this tabular form. So right now, we assume that you have done that using another cloud platform or any other from a server, okay, where you collect all this data from multiple devices, okay, and you have integrated it. So that technique is called integrating. So I have also shown you how Cisco and Teradata is actually developing a framework, so that will help you to seamlessly integrate all these sensor data. Okay. Now there's a function in called head. So if you want to see a few rows of your data set, like what the actual values of your data set looks like, then you can run this cell. So the data set dot head. Okay, so this function will display your rows. Okay, here you can see this is a time, so don't worry about the time here. It is actually in a Unix format. So I'll help you to convert that into the time, the actual time. Okay, so we have a separate function for that. So right now you can assume that this is a time data that has been stored by this data set. Okay, then we have the values for use, total energy generated, and the overall house energy usage, and you can see also the different appliances energy usage. Okay, and also the weather data set where the temperature, humidity, visibility, and other values as well. Okay, so almost all the values are numeric, and only this icon here is a clear night, and also the summary. You can see summary as it's clear. So these are categorical, and don't worry about this cloud cover. In cloud cover, right, a lot of values are numeric only, but there are some value which is categorical. So there, that also we will see how we can convert it into a numeric. Okay, so that is the data set view using head function. Okay, now I'm skipping this step. It just displays the type of your data. Okay, you can see all are floating types and some are objects. Okay, so floating types because you have fractional parts as well for most of the data. Okay. Now you have to come to this cell. Okay, so when you run this cell, it displays the number of rows. It's already displaced. It's already displayed using the info function. Same thing only. So your data set dot shape will tell you the shape of your data set. So the first item is the number of rows, and second item is the number of columns. You can also specifically call by using dataset dot shape of 0. So shape of 0, that is the index that will give you the number of rows, and shape of 1 will give you the number of columns. Similar to the head function, if you are passing some arguments to this head function like 10, when you run it, you can see all the first 10 lines. Okay, from 0 to 9. So the index is actually starting from 0. So 0 to 9, you'll be getting first 10 rows. Similarly, there's a function called a tail function. So that will show you the last 10 lines as well. Okay, here you can see, and when you run this tail function, you can see that the last line is having a lot of NaN values. In Python, NaN value, that means there is no value for that particular row. So it's actually not 0. 0 is a meaningful value in the machine learning world, but NaN is not. Okay, so you may have to remove those NaN values, or maybe if you have to replace it with some other values. Okay. So that's the quick data analysis. We have seen the entire data set. We have seen the head part, the tail part. Okay, now you have some idea about the values in the data set. Now, the next step is to do some kind of data pre-processing. Okay, so let us do some cleaning to your data. So as I said, the last row is having NaN values. You have to actually remove that row. Okay, for that in pandas you can use the slicing. So you can actually slice out some rows. Okay, so how to slice out rows in pandas? So this is your data set. Okay, this is the slicing operator. Here the first index shows you start from 0. Okay, and you go up to -1. Okay, so -1 means it is the last row. Okay, but this slicing operator, if you're giving, it says you start from 0 and you go up to 2, that means the slicing will slice out 0 row, first row. It is the second index is excluded, so you are actually not getting the second row. So it will print your 0th row and first row. Similarly, if you are putting 0 to -1, it will exclude the last row. So that's the slicing. Okay, now when you do the slicing, when you print it again, you can see that when you do the tail function, the last row is removed. So that is one method to remove rows from your data. So this you may face these kind of issues where you have a lot of rows with NaN values. So you have to actually remove all those rows. So this is one method using the slicing. Okay, and it's not like you have to always start with 0, you can also start with any index as well. Okay. The next one, I'm just displaying the column names. Okay, so now when you look at these column names, you can see now there are a lot of KW units also showing with the column names. So I just want to remove all those KW no, that's in square brackets, so that my column names is more readable. I don't want to always display the unit along with the column names. Okay. So for that, we have a replace function in Python that will replace all the column names, by removing this KW. Okay, so you are going to
Excuse me,
call the
sir.
replace. Yes, yes, yeah.
Some participants are reporting that they are not able to follow the Kaggle since they can only see 3 cells.
They can only
See 3 cells. Cell
no,
4
no,
onwards they can't see.
no. They can just check the link I've shared in the GitHub. Okay. In Kaggle, so when you go to this GitHub page, there's a Kaggle notebook here. Yeah, I'll paste that in chat box also. Okay. Just click on this link, then you'll be able to see it. So the link that has been shared yesterday is for you to test it. Okay, that is only a sample. So this is the actual link. So it is already there in the GitHub page. Okay.
Okay, sir. Can you wind up within 10-12 minutes?
Yeah. I'll wind up. Yeah.
Okay.
Okay, so that's the way to replace the column names. Now, the next part is about feature engineering. So we have seen that in the machine learning pipeline, where now you have to perform some kind of feature engineering. So here I will show a simple example where you can perform feature engineering. So we already have this furnace 1 data and furnace 2 data, right? So you don't have to separately use that in your when you try to build your machine learning model. So what you can do, you can just add up those two values so that you have a new field that is called sum of the furnace. Similarly, you don't want to keep this kitchen 1 2 kitchen 1 4 kitchen 3 8. Okay, you can just combine those columns together. Okay, so here you have a new column. Okay, that is average kitchen usage. Okay, so this is some kind of a feature engineering. So you already have your columns with you, you already have your features with you. You are going to feature engineering and make some new columns. Okay, so in pandas, this is the way to sum up these values. You can use dot sum function. Axis is equal to 1 means you are summing along the column, and here you're taking the mean value along the column. So you are adding up kitchen 12 40 and 38, and you're taking the mean, so that is the average kitchen. So this is some kind of feature engineering. So this will be useful when you try without this feature engineering, and when you try with feature engineering. If you're able to improve the performance of your model, that means your feature engineering works well. Okay. Now, once you have created new columns, you can easily drop the previous columns. So you can use the drop function. When you run this cell, it will drop the previous columns. Now comes the time. So as I said, it is in Unix time format. So this particular value, it shows the number of seconds that have been passed from 1st January of 1970. Okay, so you have to convert this timestamp into a readable date and time. Okay, for that you can use this code. Okay, that will convert your timestamp into this date and time. Okay, so you can run this code. So this is a code that has been used for converting your timestamp into time. Okay, and you can do this for the entire data set. Okay, for that I'll be using it here. Okay, starting from index 0, and you are going to convert the entire timestamp of the entire data set. Okay. And according to the data set that has been given, the frequency of this time is a minute. Okay, so so it's pretty easy for us to convert this timestamp by adding 1 minute. So your time start from 1/1/2016. That is the first timestamp value. Then after 1 minute, so it is 51, 52, 53. So you are actually changing the time stamp values to date and time for the entire data set for 50,000, 3, 9, 10 values. Okay, so this is data set shape. Okay, now as I said, you can use matplotlib to visualize your data. So let us look at some of the data values. So I'm going to plot the figure for the temperature. So here you can see the data set for the temperature. Just a second. Okay, so data set for the temperature, and here this is a plot. So the x-axis shows the date, and y-axis it shows the temperature value. So you can see a lot of fluctuations because you are recording the data in minutes. Okay, now we have a lot of techniques in Python where you can resample your data set, because you don't have to always work with data sets say, because the temperature won't actually change every minute. Okay, maybe it will change maybe every hour. Okay, so you can resample your data set. Maybe you can also resample it to every day. Okay, so here I'm resampling it with every day. So here there's a rule for that. I'm calling the resample function. Rule is equal to D. So this is a resample data set for every day. So there, here the fluctuation is very less because we are resampling it as a day. Okay. So there are many rules that you can try out. I have displayed it over here. You can just change this rule is equal to D. If you want to change it to H, you will be getting resampled with hour. Okay. Now let us look at the columns, and there are another value in your data set that is called use. Okay, so we have seen the resampled value of use as well as resampled value of house overall. So when you look at these two features, you can see that they are the same. Okay, that means if you're keeping the same features in your machine learning model, that may not be always good. It will not. It will actually decrease the prediction performance. So you have to remove one of the feature. So if you want to identify it, maybe you have to do some kind of plotting like this. So this is also a part of feature engineering where you will remove similar features from your data set. Okay, so I am removing one column, that is house overall. Okay, now I'm just looking at the icon data set, icon column as well as summary columns. They are not numeric. So for the time being, I'm just dropping out all those columns. Okay. And regarding the cloud cover, so it should be actually numeric, but there are some values which is categorical. So we have to remove the categorical values from the numeric data set. Otherwise, it will create issues when you work with the model. So for that purpose, there are different techniques in Python. One of the technique is to either replace it with 0, or you can remove the entire row, or maybe you can fill it with the nearby values, right? If you have some values, say for at 5 a.m. and the cloud cover may not change in 5:1 a.m. So you can just replace it with the nearest values. That is one way of working with missing values or incorrect values. Okay. Now that's all with the preliminary data analysis in Python. Now let us go to build a machine learning model using a deep learning technique. Okay, so here I'm going to use a data set, and in the data set I'm going to use only one column right now. I can actually use all the features column. So to make it very simple, I'm going to only use the data set, the data column, that is use column. So this is a use column here you have, and this is a time. Okay, so what I've done is I just converted into date. Okay, so this the index is now date. Okay, here you can see for 1/1/2016, 2/1/2016, and the corresponding usage. Okay, that is a data set that you have now. Okay, with two columns. Now I'm going to create a data set. So as my problem is to know the energy usage for the past 30 days, and I want to predict the energy usage after 5 days. Okay, that is the way to deal with this problem. So for that, I'm going to use a function. So there's a function already defined here that is called addLux function. So that will create a data set like this. Okay, so here you can see these columns t minus 29. So the t value is the current day, and t minus 29 is the past 29 days. So you have total 30 days with you, and what you're going to do, you're going to predict. So the y value is the use after 5 days. So this is the prediction that you have to make, and this is the training data set you have. So this is your X, your features, and Y is your label. Okay. Now, how you are going to divide your training set and testing set? Okay. So in time series data, we call it time series data because your data set is having one column, that is date here. So here you're going to slice from starting to 30th October 2016. You will use that for a training purposes, and the testing slice from 2016 11/1 and till the end of the data set, you're going to use it for testing purposes. So you can validate whether your model will perform better or not. Okay, so here we are going to divide your training, your S train, Y train from your training slides. Okay, that is your feature and your label. Similarly, your X test and Y test. Okay, you're splitting 80% in training and 20% of the data set as testing. So since you have converted this data set into days, now you have only total of 274 days for training, and you have only 41 days for testing. Okay. So the next step is just to convert your data frame into a NumPy array. Okay, so you have to convert into a three-dimensional figure because the machine learning model that I am going to use here, it will accept only three-dimensional data. Okay, so you have to pay attention to this last one over here. Since we are using only one feature here that is used, it is 1. Okay, this 274 is the number of rows in the training data set, and 30 is the time steps, that is 30 days. Okay, and this one is only one feature you have. If you're going to add say more features, like you can also have other information, that this one will change. Okay, so that is the shape of the training data set, and this is the trace shape of the testing data set. Here you have 41 samples. Okay, now before going to build your model, so may I get 5 more minutes to discuss the theory part for this model? Yes, Ranjit.
Yes, sir.
Okay. So I'm skipping this initial theory part about sequence data and all. Okay. So I just want to show so how we are going to use this temporal data set, and how we are going to use a deep neural network. Okay. So usually in deep learning, okay, so we are going to use this input layer to read the features. Okay, so here you can see these are the features of this particular data set. Similarly, in our scenario, we are going to use our features, that is use energy usage. Similarly, you can also add more features to this model, like you can also add weather information like temperature and all. And what is the final output that you're going to do? The output that you're going to predict is the energy usage after 10 days. So there we are going to use a recurrent neural network. Okay, so where each frames you can think like it's each time steps. Okay, so where you are going to use time information along with your features. Okay, so what is a recurrent neural network? So recurrent neural networks, it is actually specialized for processing sequence of values, and here you can see this x values. So this x values is your features in time step 1. So here we are going to send the time step value of day say t minus 21. So this is t minus 28, and this is t minus, so this is t minus 1, and this is t. Okay, and what you are going to predict, so to a recurrent neural network, you are going to predict your y value after t plus 5. So this figure shows actually the input data. So this is from here you have actually the input that is coming, but this arrow shows there is some dependency between the previous days and the next day. So that is the way this recurrent neural network has been built. Okay, so this the current neural network is used to build our model. Okay, so let's say it's a deep learning model. So let us look at the code now. Okay, so here we are going to use a sequential API to build this recurrent neural network. Okay, and we are going to use a special cell in recurrent neural network that is called LSTM. Okay, so there is some disadvantages for using an a recurrent neural network. So like recurrent neural networks suffers from a short-term memory. So since you have 30 days of data with you, and if you are going to use only a recurrent neural network, it actually suffer from issue called short-term memory. Okay, so to overcome these limitations, we have a new cells that has been developed nowadays. All the recurrent neural networks is actually using this LSTM cells. It has got an inbuilt memory in it, okay, using gates. So it will store this information inside these LSTM cells. Okay, so that will capture this long-term dependency, so that the previous issue of recurrent neural network has been handled with the help of LSTM cells. That is why in the code you are actually seeing LSTM cells. Okay. Here you can see the number of units in the LSTM cells, and you can see the return sequence is true. So there are two layers of this LSTM network, and you are sending your input data to your recurrent neural network. So the xtrain 3d.shape one column. So one column means you're actually not sending the entire 274 rows together. You are only sending this part to your recurrent neural network or your LSTM. You're sending the entire time steps. So the 30 days data has been sent to your recurrent neural network, and you are only sending the energy usage data. Okay. Now what about this 274? So this recurrent neural network, you have more iterations, more forward passes. There's a technical backpropagation. So for each forward pass, it will take one sample at a time. Okay, so here you're sending 30 and 1, okay, to your LSTM cells, and this is the model summary. You have your input data, that is 30 time steps. You have 100 units in the LSTM cells. Okay, then you connect that to another LSTM cells above. So in the previous figure, here you can see you have a LSTM cell like this. Okay, these are the input for day 29 minus so t minus 29. This is output of t minus 29. So you have corresponding outputs. You have one more cell over here, and in the final, I'm making return sequence is equal to true here. That means you will have this y value corresponding to each cell, but in the final output you have only the output after 5 days. You have only one output value. You connect that to a dense layer, so this code will connect to the dense layer. So when you run this cell, you can see the model summary. Okay, now next step is to train the model, and for that you have to combine your model that is developed using a loss. So here we are going to use mean square error. So it will compare the predicted results, predicted value, and it uses mean square error. So it will actually square the difference. Okay, the predicted results and the actual results. It will square it, and it will take the mean. Okay, that is a loss function that we are going to use. We are going to use the backpropagation to train against this loss function. And there is a optimizer that we are going to use. The one Adam is a popular optimization, and this mean absolute error, you're just taking the absolute value and you take the mean. So that is the mean value that you are going to see here. That is a performance matrix for your training stage. So when you compile it, you can see the validation loss and mean loss. So once you do that, now you already have kept 20% of the test data with you right now. Okay, here you can see the Y test and the S test data. Now you're going to evaluate the performance of your model using the test data set. Okay, here you can see the mean absolute error and the loss. So when you run it, you can see the loss. So here the energy usage is having a mean absolute error of 0.16. Okay, so that is the final performance measure that you got after running this model. As an exercise, you can run this cell by changing the number of units. You can add more layers. You can experiment with this exercise also. Okay, so that's it. That's it with the hands-on session. Yeah, Francis, completed. Do you have any questions?
Hello. Sadis sir, can you please switch on your video and interact?
Sure. Yeah. Okay.
Okay, thank you, sir. Uh, you took a brilliant effort to add all this content within this 1 hour 30 minutes class. Actually, he was one of the trainer, machine learning course trainer in our college, and he's doing his research in this area itself. So he's an expert. So the participants can interact him with later. Those who are attending this class first time, it's difficult to follow the contents fully, but the links are provided, shared to you, the notebook and in Kaggle as well as in GIT Hub, GitHub, it is there. So you can study yourself. Those who are just beginners, this can be a good start for you, and you can develop your own. A lot of contents are available. You can interact with the faculties at sir also. So I thank you, sir. So you put a good effort for squeezing all this contents within this 1 hour 30 minutes. Thank you, sir. Okay.
Yeah, thank you, ma'am.
Participants, if you want to thank or want to comment on session, you can have. Please unmute them.
Thanks a lot, sir, for your good session. It was really beneficial for us.
Yeah, thank you. So in Kaggle, you can actually have the options to comments. So if you have a doubt with any code, there itself you can comment. So I can get back to you for those issues and all.
Thank you, sir. It was a very good session, sir. We need some more time to understand, sir. It was very good session, sir.
Yes.
Thank you, Sarit sir. Suyog here. So can we use the same link for practice in future also? Will you keep that alive?
Yes. You can use the same Kaggle link.
Kaggle link.
Yeah, you can use the same Kaggle link. You can edit and it will be your own copy. So you can modify the code and you can try it yourself. Okay.
Okay. One request, sir. Can you please paste that link once again? I missed the initial link.
Okay. So I'll paste you the GitHub link. So that from there you can get all the PDF of the PDF presentation. Then also you'll be getting the data set. Everything is there. Okay. So I'll paste the GitHub link.
Thank you, sir.
So we wind up the session now.
No, it was very informative session, sir.
Yeah, thank you.
Sir, please share your mail so that we can future contact with.
Okay. Okay, for beginners, I suggest you to take a course in Coursera, so that will be very useful. So there's a Python course in Coursera.
So the title of the course, is it Python for everybody or something?
Yeah, Python for everybody. I'm talking about the machine learning course. So there's a deep learning course by Andrew Ng. So it will be very useful if you want to work with machine learning and deep learning. And for Python, Python for everybody is also fine. It's a very basic course, and you can also have a look at one of the repository, Python repository in GitHub. So I'll share you in the Kaggle itself. Okay, so I'll add those extra materials also in GitHub, so you can go through that also. Okay.
So thank you, sir.
Okay, thank you. Yeah. So shall I leave?
Yes, sir.
No, okay.
Now we will have a 15 minutes break. We will start the next session by 11:45. So you can take a break now. Okay, I think we can take a 5 minutes break. It's already 11:40.